Conditional probability gives the probability of one event occurring under the condition, given that another event already happened.
The thing you guys see between A and B, like the mark, just means that A, like, given B already happened. So probability of A, mark B is the probability of A given that B occurs. And probability of B mark A is the probability that B given A occurs. That just means that, like, B already happened, and what's the probability of A occurring? Or like A already happened, and what's the probability of B occurring? When probability of A is greater than 0, the conditional probability of B, given that A already happened, is is the equations you guys see down there. And yeah. The multiplication rule is that probability of A and B occurring together. And that is probability of A and the probability of B equals probability of A times probability that A has already happened and B is occurring. And then intersection is a set of outcomes in which all events occur.
Independence is a set of outcomes in which all events occur. To show that two events are independent, you must show either that the probability of A and B equals the probability of A times the probability of B, or that the probability of A given B equals the probability of A, or the probability of B given A equals the probability of B. Basically, you have to show that the probability that an event occurs is not changed by even if another event occurs before it. Okay, and Bayes' rule. If A and B are any events whose probabilities are not 0 or 1, the probability of A given B equals the probability of B given A times the probability of A divided by the probability of B given A times the probability of A plus the probability of B given the complement of A times the probability of the complement of A. Right, now we have a few review questions for you. And you can pause the video after each one so you have time to answer them. But for problem 1, Skittles have the following distribution of colors: 25% red, 20% purple, yellow, and green, 15% orange. If you pick 4 Skittles from the distribution plan, what is the probability that A, all 4 are purple, B, the third one is the only red one, C, none are orange, and D, at least one is yellow? Here is where you may want to pause the video. The answer to A is 0.0016. The answer to B is 0.1055. The answer to C is 0.5220. And the answer to D is 0.5904. Problem number 2. If you roll a die 4 times, what is the probability that A, you roll all ones, B, you roll all even numbers, C, none of your rolls are 3, D, you roll at least 1 2? The answer to A is 0.0108. The answer to B is 0.0625. The answer to C is 0.4823. The answer to D is 0.5177. Question 3. For each pair of events, classify as independent or dependent, also if they are disjoint or not. A, doing homework and getting a B or higher in the class. B, oversleeping before school and getting stuck in traffic on the way. C, being an MHS student and being friends with George Washington. D, having a broken light bulb in the living room and a dishwasher dying. A is not independent. B is independent. C is not independent. And D is not independent. A is not disjoint. B is not disjoint. C is disjoint. And D is not disjoint. Question 4. The probability that a call to 911 is an actual emergency is 0.3. What is the probability of of 3 successive calls, only one is an emergency? A, 0.246, B, 0.063, C, 0.147, D, 0.21. C, 0.147 is the correct answer. Problem 5. The MHS fire alarms have a main and a backup power supply that are independent of each other. The probability that the main system will fail is 0.02, and the probability that the backup will fail is 0.08. What is the probability that both systems will fail? And what is the probability that at least one system works? The probability that both systems will fail is B, 0.0016. The probability that at least one system works is D, 0.9984.
Alright, so now is the open response part. So the MHS Sports Department has gathered information about senior soccer and cross-country athletes. They know that 65% of these athletes play soccer and 75% of the soccer players are boys. Of the athletes that run cross-country, 55% are girls. First part is, given that a boy is picked, what is the probability that he plays soccer? Part B is, given that a girl is picked, what is the probability that she runs cross-country? These two are similar, and the last one's about independence. Are playing soccer and being a boy independent of each other? Justify your answer with mathematical evidence. We did a tree diagram for organization. You could pause the video and make a tree diagram and answer the questions and see if it matches. This is a tree diagram that we did. 0.65 for the soccer and 0.35 for cross country. And then the boys 0.675 and then 0.25. You guys could see the numbers. Then we multiplied 0.65 times 0.75, which equals 0.4875. Then we did 0.65 times 0.25, which equals 0.1625. Then we did, and that's for the girls and boys respectively. And then there is 0.35 times 0.45, which equals 0.1575 for the boys who play cross country, and 0.35 times 0.55, which equals 0.1925 for the girls who play cross country. If you add all the red ones together, it equals 1, and that just means that the sample space. Part A is, given that a boy is picked, what is the probability that he plays soccer? And that's the equation you would use, that given B occurred, what's the probability of A? And so what you did was that, what's the probability of both A and B? So of probability that that the person playing is a boy and he plays soccer, and that is 0.4875. That's directly from the tree diagram. And then we added all the boys who play sports, which is 0.4875 plus 0.1575, and that equals 0.7558. And then the B was, given that a girl is picked, what is the probability that she runs cross country? So probability that girl plays cross country is 0.1925, so that's A and B. And then we added the probability that a girl is playing a sport, either soccer or cross country. So 0.1925 plus 0.1625, and that equals 0.5423. Third one is about independence. So this is the independence rule for the multiplication rule for independence events that is being used here to prove that they are or not independent. Probability of a person being soccer and a boy is again 0.4875, and then probability of A, which is the probability of only playing soccer, and probability of B, which is probability of only being a boy, is probability of A and probability of B. And then you multiply those, which equals 0.4193. 0.4193 does not equal 0.4875, which means that playing soccer and being a boy is not independent. Thank you so much.